So we have our group G with 8 elements, and we have our subgroup H with 2 elements, right? So order of G is 8, then order of H, which is the subgroup, is 2. So basically the number of cosets we will have is order of G divided by order of H, right? So we have order of G, which is 8, order of H, which is 2. So we will have 4 distinct right or left cosets, right? So let's start with finding left cosets. So we have first identity H, right? Then we do BH, then we do B square H, then we do B cubed H, then we do A H, then all the elements of G, right? So this is the left coset. Now for the right coset, we would do H identity, then HB, then HB squared, HB cubed, right? So HB, then HB squared, then HB cubed. That's what we would do if we didn't know like any shortcuts. So let's start with the left coset. For the left coset, H identity is the set that you compose identity H. So you compose identity with every element of H, right? So identity composed with identity is identity. Then you have identity composed with B square, which is B square. Now this is basically H. As you can see, identity H is the same as H, right? Now BH is, we compose B with every element of H, right? So B composed with identity is B, then B composed with B square is B3. So this is BH. Now B square H is B square composed with every element of H. So B square composed with identity, then B square composed with B square, right? So B square composed with identity is B square. B square composed with B square is B4, but B4 from here is identity, right? So we have identity. B cubed H is B cubed composed with identity, then B cubed composed with B square. So B cubed composed with identity is B cubed, then B cubed composed with B square is B5, but B5 is B4 composed with B, and B4 is identity, so we have B. So we have A. Now we have A H. So A composed with identity, then A composed with B square. So AH is A composed with identity is A, then A composed with B square is A B square. Normally is A B square, but in this group we don't have A B square, so it must be something else, right? So A B square, let's say A B square is basically equal to, as you can see here, AB is equal to B cubed A, right? So we have AB square is equal to AB B, and AB from here is equal to B cubed A, so this AB would be B cubed A. So this is B cubed A B. we have AB again, which is b cubed a, so this is equal to b cubed, then b cubed a. Now b cubed is b6, right? b6 is b4 b square, right? So this basically is b6 a, which is b4 b2 a, and b4 is identity, so this is identity, so basically this is b square a. So this ab square is the same as b square a, and b square a is an element of the group, so here we would write b square a. Now we keep doing this for all the elements of the group G, right? Let's delete this. So we have AH. Now the next element is AB. So ABH is AB composed with elements of H. So AB identity would be AB, then AB B square. So AB B square would be AB cubed, and AB cubed is not an element in this group, so we have to change it. AB cubed is basically AB B square. AB is B cubed A, so this is B cubed A, then B square. Now we have, this is basically equal to B cubed A B because B square is BB. Now we have AB in the middle, which is B cubed A, so this is B cubed, then B cubed A, then B. So what we have here is B6. B6 basically is B square because B4 is identity, right? So this is B square AB, but this AB is B cubed A, so we change it again, B square then B cubed A. Here we have basically B5, which is B because B4 is identity, so this is BA. Now BA is an element of this group, so we write BA here. Yep. Now what we have to do is this one here, BA composed with H, right? So BA composed with H. BA composed with H is BA composed with identity is BA. Now BA composed with B square is BA B square. BA B square is basically equal to, here we have, this is equal to BABB because B square is BB. Now AB is B cubed A, so this is B, then B cubed A, then B. So we have B4 here, which is identity. From here B4 is identity, so we have just AB, and AB is an element of this group, so this is AB. Now the last element is B square A, right? So we have B square A composed with H, so B square A composed with identity is B square, this identity, b squared a composed with identity is b squared a. Now b squared a composed with b squared is b squared a composed with b squared. This is equal to b squared a b b. Now this ab in the middle is b cubed a, so we have b squared, then in the middle b cubed a, then b. Now this is basically, this is b5, which is basically b, because b4 is identity, then b ab. Now this ab is b cubed a, so we have b cubed a, and that is equal to a because this is b4 and b4 is identity, and a is an element of this, so this is a. Now these are all the left cosets we have, all the left cosets, but from this we said that we have only 4 distinct left cosets. As you can see, this is 1 2 3 4 5 6 7 8. We have 8 left cosets, but we have 4 distinct, so it means that there are some of them that are the same. Let's see. So here we have identity b square, here we have identity b square, so these two are the same, right? So here we can say that they are the same. Identity H is this set, which is the same as this set, right? Now here we have b cubed, here we have b cubed, so this one and this one are the same, right? So let's delete this, so we can say, okay, this one is the same as this one here. Now here we have a b squared a b squared a, so this one here is the same as this one here. They are the same. Now here we have ab ba ab ba, they are the same, so this one here is the same as this one here. So in total we have 1 coset, 2 3 4 distinct left cosets, as we expected to be. Now we do the same for the right coset, and then we're gonna realize that left coset is equal to right coset in this case.